Hello friends, in this session we will see some problems based on stability in time domain. Let us begin. Now, GATE 1991 question. Very important and easy question as well. Say, see, a unity feedback system has an open loop transfer function of the form. This is the transfer function. Okay. In that, if you observe, yes, definitely they are saying that B is greater than A. B is greater than A, which means definitely this pole which is there, it is far away than the zero from origin. Okay. Yes. Which of the following root loci is the valid? These are the options. Four options given. Okay. Yes. Now, next thing, if you check out what is there, yes. Now, if you just observe, you have got these two poles at origin. Is that right? Yes. And you have got this one pole here, and you have got 1 0 for that pole, which means that definitely this pole has to terminate at some 0. Is that correct? Yes. Now, if you check out, is my pole terminating to a? Yes, terminating here. Is my pole terminating to this 0? Yes, it is terminating. Is my pole terminating to this 0? We can't understand actually. This definitely is not the answer. Why? Because this is going here, but then there are some poles coming here also traversing here. Definitely this is not the answer. And then yes, this one also, if you see, yes, B is entering into it. No problem. Poles are ready. Now, at least one option has been eliminated. Now, what will help us? What will help us? Asymptotes. Because we know that for those poles which end up at infinity, we have got angle of asymptotes. What are they? Let us try to see. So, angle of asymptotes. Okay. Which is denoted by phi a. We know that it is equal to 2q plus 1 into 180 degrees upon p minus z. Is that correct? Now, what is p minus z? Yes, definitely you see you have got this is 2 pole and this is one more pole. Right? P minus z. P minus z. What is that? P minus z equal to? P minus z is nothing but equal to 3. P minus z is equal to 3. So, you get that P minus z is equal to 3. Now, what do you put here? You please put 2q plus 1 into 180 degrees upon 3. Now, what will we do now? See. What will I do? I will put first q equal to 0, then put q equal to 1, and then put q equal to 2. Correct? Yes. If I put q equal to 0, what do I get here? I get 180 degrees by 3, which is equal to 60 degrees. If I put q equal to 1 here, what do I get then? I get 2 into 1 plus 1 upon 3 into 180 degrees. What does that mean? It becomes 2 into 1 plus 1 is 3 by 3. 3 by 3 into 180 degrees is nothing but same as 180 degrees. Then next, if I put q equal to 2, what do I get then? I get q equal to 2, then it becomes 2 into 2 plus 1 upon 3 into 180 degrees. What is that? 2 into 2 is 4, 4 plus 1 is 5, 5 by 3 into 180, which is equal to again 300 degrees. So what do you get then? You get that. You understand that definitely the asymptotes which are there, those are. Now, what is the centroid? What is the centroid? So for that matter, what is centroid? Centroid is nothing but summation of real part of pole minus real part of 0. So it is going to be summation of real part of pole minus summation of real part of 0 upon p minus. Is that correct? So upon p minus z is going to be 3 only. Real part of pole. What is that real part of pole? Pole is nothing but s plus b. Is the pole? No. S plus b equal to 0 is the pole. So s is equal to minus b is the pole. So it becomes sum of real part of pole is nothing but what? Minus b. What is minus? Summation of real part of 0. Where is your 0? 0 is s plus a. So s equal to a minus a is the 0. So, right? So, if you put here s equal to minus a, so if you put minus a, you get this. So, you get minus b. This minus into minus will become plus. So, minus b plus a upon 3. Is that correct? Yes. This is nothing but your centroid. So, if you check out, this centroid will be somewhere close to the origin itself. It means what? It means what? This centroid is, let us say here, somewhere close to the origin. What is happening now? Angle of asymptotes. If you take 60 degrees, definitely 60 degrees. Then if you check out 180 degrees, 180 degrees again here, 180 degrees. Then next is what? Next is 300 degrees. 300 degrees is where? Again here down. Correct? Which means, which out of the following will be the answer. This is definitely not the answer. Now we have to choose between this and this. Which one you feel is more appropriate? Definitely it is going to be D, right? Why? Because one is in this direction, then you have this in 60 degrees and this in 300 degrees. Is that right? Yes. But if you check out here, what has happened? The direction has changed somehow. Direction has changed here. Direction has changed here, which means this is no longer 60 degrees now. This has become, I guess, 130 degrees or somewhere like that, right? Which means this is definitely not the answer. Why? Because the asymptote is what? This is 60 degrees. Then this becomes 180 degrees. And this complete becomes 300 degrees. Is that correct? Yes. So definitely option D is the answer. Option D is the correct answer. I will make it a note. Option D is the correct answer. Okay. Now we will try to solve some more problems. Yes. Now the algebraic expression is given. This is the algebraic expression: s power 5 minus 3 into s to the power 4 plus 5 into s cube minus 7s squared plus 4s plus 20 is given, right? If f of s is equal to 0, it has what? It is basically GATE 2006 problem. Okay. Now if you just see what can be done, if you treat this particular f of s equal to 0 as a characteristic equation, if you just treat that to be equal to characteristic equation, then yes, definitely you can find out whether how many poles are there which are on the left half of S plane, right half of the S plane, as well as the imaginary pole values, right? Yes. So we will try to form that particular array. We will see. So for that, let me just write down this f of s to be equal to whatever is at one more time over here, so that will become easy for you. Okay. So this is the equation, correct? Now I will write s to the power 5. What will I do now? Definitely alternate. I will have to put, so here I have nothing, which means here I have 1. So this becomes 1. Then this becomes 5. Then 4. Is that correct? 5 and 4 and this 1. Now what is next? S power 4. What is s power 4 now? Minus 3, minus 7 and 20. So minus 3, minus 7 and 20. Is that correct? Is that correct? Yes. Now let us find s power 3. What is s power 3? Let us see. What will be s power 3 here? Yes, definitely this into this minus this into this upon this, correct? So if you solve that, which means see, minus 3 into 5 minus minus 7 into 1 divided by minus 3, correct? If you solve this, you get the answer to be equal to 22 by 3. So this is nothing but 22 by 3. Okay. Yes. And then next is what? Yes, next is what? This minus 3 with this 4 minus 0 into this 20, and you will get somewhere over here. What do you get then? The calculation is like this: minus 3 into 4 minus 1 into 20 upon minus 3. The answer that you get here is nothing but 32 by 3. Is that correct? Yes. Now let us find what is a square row. For a square row again, we will do what? Yes, this into this minus this into this upon this encircled element again, which means what is that calculation? That is nothing but 22 by 3 into minus 7 minus minus 3 into 32 by 3 divided by 22 by 3. After solving this, you will get the answer to be equal to minus 2.636. Is that correct? Yes. Now what is s power 1 here? What is s power 1? Yes. See, definitely this 20 will get copied here again, correct? Yes. Now what is s power 1? It is nothing but this into this minus this into this upon this, correct? Which means it becomes what? 22 by 3 into 20 minus 32 by 3 into minus 2.636 upon minus 2.636. If you solve this, you get answer to be equal to 66.30. And yes, at s power 0, what will happen? This 20 will get copied here. Is that correct? Yes. Now what happens in the first row here? First column here, what has happened? This was positive. First was positive, second became negative. Means there was one sign change here. Then definitely third again became positive. So definitely there is second sign change here. Then what happened? Again this positive became negative over here, which means you have third sign change here. And then definitely this negative again became positive. So again fourth sign change here. And this positive remained positive. So there is no sign change here. So definitely total you have how many sign changes? You have got four sign changes. What does that mean? You have four poles on right half of a plane. Right half of a plane. What does that mean? Where is that option? Yes. You have one negative. See, you have got these four complex roots with all positive real roots. Positive real roots means what? Definitely on the right half of a plane, because you see, this is the S plane, right? If your pole is here, what does that mean? That the real part of the pole is positive. This is positive axis, right? Which means real part of the pole is positive. Real part is positive. That is what they are saying. So we have seen that there are four poles on the right half of S plane, which means there are four poles having positive real parts, right? So definitely there are four complex poles which are having positive real parts. And what is there? Definitely you have got this total five, right? Out of which four are on the right half of S plane. So definitely one should be on the left half, which is the negative real axis, right? So definitely this is option B. Option B is the correct answer. Now we will see some more problems. Yes, it is GATE 92 problem. Which of the following figures represent valid root locus in the S-plane for positive k? For positive k, okay. Assume that the system has transfer function with real coefficient. Okay, assume. Let us see. What do you say? Option C first. What is there in option C? If you see, we have seen that root locus is always symmetric about real axis. But if you check out now, here it is not symmetric about real axis, which means definitely it is not the option. It is a wrong option. Okay. Now let us see B. What is there with B? See, there are two poles on the right half, right? Yes, it's okay. There can be poles. There is no problem. But if you see, is this a root locus area or not? Yes, it is a root locus area between these two poles. Why? Because if you hide this particular area on the right, you find one pole. One pole means what? Odd number of poles and zeros, which means this is definitely root locus area. Root locus area, correct? Yes, which means definitely breakout must have happened here, but breakout has not happened. Similarly, if you again think of what is this, that the root locus is starting at the pole and again entering into another pole, this also doesn't happen. So which means again option B is also wrong. Now let us see what is option D. Option D has no meaning actually. Where it has started, where it has gone, what is the thing, no one knows anything about it, which means option D is also wrong. It is meaningless option, right? Because you you just simply don't know what is the direction. Number one. Number two is what is happening here. See, here definitely this is root locus. Definitely something, some breakaway point should be there here. Is it there? No, which means definitely this again becomes. So now, which one is that? Option A. Is it right? Let us first verify. It has to be right, but still we will verify. See, is it root locus area? Yes, it is a root locus area, which means definitely there is a break-in point here. Yes. There are two poles, so the two poles have to terminate at two zeros. Two open loop poles which are there, they will have to terminate at two open loop zeros, correct? So definitely, now see here again if you see this one, is it a root locus area? Yes, because you have 1, 2 and 3, you have three number of zeros and poles, right? Which means what? It is odd number of, right? Which means this is the root locus area. So yes, definitely there is a breakout here. There is a breakout, and since here you have two zeros, this has formed a circle here, and they are going to terminate into the zeros. So yes, option A is the correct answer. Option A is the correct answer. Now we will see some more problems. Yes, it is a GATE 2005 question. What does the question say? The question says that figure shows the root locus plot. Okay, root locus plot. Location of the poles not given. Location of the poles are not given. Of a third order system, okay, whose open loop transfer function is. They are asking the open loop transfer function. What has to be the open loop transfer function of the same. You please tell me what it should be. Let us see. By the way, here also there is error. Okay. Yes. Now we will see what it will be. See. Let us see. They have not at all given you locations of poles. They have only given you the asymptotes. These are asymptotes. These are all these black lines which are shown. They are all asymptotes. Asymptotes are shown. Right. Now see. If you just check out, since entire negative real axis has root locus. See, this entire negative real axis has root locus, right? It means that all the three poles at origin, all the three poles are at origin. How do you understand that? How do you understand that? Because if you see, if this entire one is here, just let me tell you, let me take some example. For example, let us say if you have all the three poles here, what will happen? What will happen then? Then if you hide this area, this entire negative area, what will happen then? What will happen? You will find that on the right you have got three poles, which means odd number of poles, which means this has to be root locus area, and definitely that is a root locus area. Yes, that is a root locus area. But now just imagine a hypothetical situation. If you have, let us say, one pole here, let us say you have got two poles here, then what will happen? Then yes, this is going to be the root locus area, but this one, right, this will be the root locus area. Is that correct? Because on the right there are three poles, but then if you see here, then no, that will not be. So you have to understand one thing, that since negative real axis entire negative real axis is there, right, is a root locus area. That is the reason we can say that all the three poles are at origin. They have to be at origin, they can never be anywhere else. They have to be at origin. So check the options. Yes, this is option A. Option A is the correct answer. Very simple question, right? Yes. Now see, we will try to see some more problems now based on the same. Yes, this is GATE 2014 question. Now see, the root locus of a unity feedback system is shown in the figure, and they have asked you the closed loop transfer function. Let me write it. Closed loop transfer function is, this is what is they are asking. Okay. Yes. Now see dear, what has happened? What is happening here? See, you need to understand one thing. Just observe this root locus. What do you say? That this has to be root locus area or not? This one has to be root locus area or not? Yes, this has to be root locus area. Why? Because towards its right you have got only one pole, which means it is A. Which means it is what? Yes, it is what? Odd number of poles, right? Which means this has to be a root locus area. Similarly, if you check out here, this area, if you see, this area should not be a root locus area, right? Which means ideally, what should happen? What should happen? Your root locus should travel like this, right? Breakpoints should be there this way. But what has happened now? What has happened now? What has happened now? Your root locus, rather than moving in our direction, it has went in exactly opposite direction. Means it should have gone like this. It should have gone like this. But no, it has gone like this toward another extremes. It means that this is not a root locus. Rather, it is a inverse root locus. It is a inverse root locus. Which means what has happened now? Which means k varies from where to where now? K varies from minus infinity to 0. If you see our only root locus which is there the k varies from 0 to infinity, but in this inverse root locus it is going to vary from minus infinity to 0. Is that correct? Yes. Now, how to find the transfer function? See, very simple. What is your h? H is going to be 1, right? They have said that unity feedback. Okay. Now, what is your g? Gh then? You are only interested into the g, right? What should be the g? Since, see, you have to understand one thing. Since it is inverse root locus, then definitely it is going to be minus k. Because it is inverse root locus, you have to use minus k. That is the first thing. Next thing is what? Whatever the poles, wherever are they, just place the poles. So you find that you have got pole here, you have got pole here. Pole at s equal to minus 1 and s equal to minus 2. So that can be represented as s plus 2 and s plus 1. Is that correct? Yes. Now see. But is this the transfer function unit? No. This is the loop gain. This is the open loop transfer function. What do you want? You want the closed loop transfer function. So the closed loop transfer function will look like, if you just solve it, g upon 1 plus gh. Then after solving this, you will get the closed loop transfer function to be equal to minus k upon s plus 1 into s plus 2 plus k. This is nothing but your c of s upon r of s. Is that correct? Yes. So the option is option B, minus k upon s plus 1 s plus 2 plus k. So option B is the right answer. Is that correct? Yes. Now we will see some more problems. Yes, it is GATE 2002 question. Now, the unity feedback system has a open loop transfer function g of s equal to k upon s square, and they are asking the root locus plot is what? What will you do the first thing? See, the first thing is there are no zeros, which means definitely these poles have to terminate at infinity, right? So what do we get then? We want the angle of asymptotes because they will move in the angle of asymptotes. It is nothing but phi a. What is that phi a equal to? 2q plus 1 into 180 degrees upon p minus z. What is p minus z? P minus z is equal to 2, so it becomes 2q plus 1 into 180 degrees upon 2. Is that correct? And this q will go from 0, comma 1. Correct? Yes. Now, if we check out what is phi a, what is phi a, dear? Phi a is nothing but equal to what? If you put q equal to 0, what will happen? If you put q equal to 0, what happens? You get 2 into 0 plus 1 upon 2 into 180 degrees, correct? Which means 2 into 0 is 0, which means half into 180, which is nothing but 90 degrees. Now, next one. If you put q equal to 1, then what you get? You get 2 into 1 plus 1 into 180 degrees upon 2 into 1 plus 1 into 180 degrees upon 2, which means 2 into 1 is 2, 2 plus 1 is 3, so 3 into 180 degrees upon 2, which is nothing but, let me just solve it one more time. It is looking quite this one, right? Yes. If you check out, if you put q equal to 1, what do you get then? You get 2 into 1 plus 1, right? In place of q, you have placed 1 into 180 degrees upon 2. What is that? 2 into 1 is 2, 2 plus 1 is 3, 3 by 2 into 180 degrees. 3 by 2 into 180 degrees is what? 2 ones are 2 90s and 90 to 3 is what? 270 degrees. Which means, what is your answer? This is 90 degrees, this is 90 degrees, and this is 270 degrees, which means definitely option B is your answer. Problem solved. Very simple question, right? Yes. Now, we will see one last question for this set, okay? Yes, it is a GATE 2006 question. What is the question asking? A closed loop system has characteristic function. This is the characteristic equation given. Its root locus plot is what they are asking. Okay. Yes, we will try to find out. If you see, what is the characteristic equation given here? Characteristic equation is nothing but what? S square minus 4 into s plus 1 plus k into s plus 1 s minus. Is that correct? Yes. Now, if you check out, this is nothing but what? G upon 1 plus g. Is that correct? Which means this denominator is nothing but what? 1 plus g only. Is that correct? So, from this, you try to find gh. 1 plus g or gh, basically. Okay. If you try to find gh, it is equal to what? It is nothing but equal to, if you try to put it this way, equal to, and then you try to find it out, you will get that it is nothing but equal to k into s minus 1 upon s plus 1 into s plus 2 into s minus 2. Is that correct? Yes, it is going to be correct. Now, see dear, let us try to write the pole 0 configuration. If you see, this becomes this way. So, this is a 0, right? S equal to 1. So, definitely here is a 0 at 1. Now, what happens next? You have got one pole also here. So, this becomes at 2. You have got one pole, right? After that, what you have got this s plus 1 and s plus 2. So, definitely the poles are going to be like this. What do you think? How it should go? Is it a root locus area? Yes, because on the right of this particular area, this particular green area, you have got one pole, which is what? Odd number of pole, which means it is root locus area. Is it root locus area, this one? No, it is not a root locus area. Is this one root locus area? Yes, it is a root locus. So this is the root locus area and this is the root locus area. This is root locus area, then definitely what happens? What happens then? This pole has to terminate to this 0 because it's the shortest one for it. And if you check out these two poles, then these two poles will come here, form here, and then they will again go in the breakaway point. This will become the breakaway point and they will break away. Is that correct? Yes. So if we check out, option B looks very similar to it. That yes, this pole is getting, what do you say, terminated at 0. Whereas, and here also you are getting this breakaway point. So definitely this is going to be the answer. So option B is the correct answer. Option B is the correct answer. Okay. Yes. Yes, dear. If you check now, you may say that, sir, but this A and this B are also similar, right? Yes, they are similar, but you need to check out two things now. See, this one. What has happened here? What has happened here? Just focus. This pole is going here also, and this pole is going here also. Getting my point? This pole is going here also, and pole is going here also. Is it possible? No, no. That is the reason this is not the answer. Otherwise, both were right. Okay. Yes. So this option B is the correct one. Now this ends. What do you say? Stability as well as root locus problems. Now after this, in the immediate next sessions, we will solve some old gate problems based on frequency domain analysis, compensators and state space analysis. Okay, thank you.